Hello everyone, I'm a third-year CVPR student at Leiden University in Netherlands. Today I would like to introduce our recent work, which is about lifelong personal education. Let's start with some background. In the past several years, personal education has got a significant progress thanks to the power of deep neural network. As shown in this table, the performance on the stationary data assumption has reached very high accuracy, even beyond human beings on some personality dataset. However, there are few literature to investigate personal identification under non-stationary data setting. But this setting is quite important for practical personal identification. For example, the stream data captured from multiple cameras all the time has a large volume, which is hard for online model training. Besides, since the private image should be privacy protected, we cannot access to previously trained data when model is training on the current domain. So we proposed a new task for person identification, namely lifelong person ID. Let's see the pipeline. The model will be trained on multiple datasets sequentially. After trained on the last dataset, we are interested in the performance both seen domains and unseen domains. Since lifelong personal education is to learn continuously across multiple domains and even generalize on new and unseen domains without accessing to previously trained domains. The proposed task has three main challenges. One is the forgetting problem on the unseen domain, and the generalization on unseen domain, and training data limitation, which means during lifelong training, the data from only current domain is available. To comprehensively evaluate a model's performance in the proposed task, we reorganize the 12 personal identification datasets to construct a new large-scale benchmark, already seen for forgetting test, already unseen for the generalization test. As for the forgetting problem, we utilize a classical incremental learning method, learning without forget, to mitigate forgetting problem. The main idea of LWF is using teacher-student network to accomplish knowledge distillation. After using FWF method in our baseline, LWF is better than sequential fine-tuning training for remembered old knowledge, but fails to sustainably accumulate knowledge for generalizing on the unseen domains when model trained on the SY dataset. Humans can execute lifelong learning well since they are relatively independent repetitions and operations in our brain, which ensure that we can finish a complex cognitive process, such as lifelong personal identification. Most existing personality methods aim to learn a good repetition and directly use it to retrieve, without considering such relatively independent sub-process. To this end, we exploit a graph convolution network to separately accomplish knowledge representation and knowledge operation. Let's overview our proposed method. First, we construct two graphs, namely ISG and AKG, to represent the new knowledge and the old knowledge respectively. Then we implement the knowledge operation by a cross-graph communication. Finally, we proposed a stability and a plasticity loss to optimize the whole network. From the experiential result, our method outperformed the compared method on both non-forgetting ability and the generalization ability. Thanks for your attention. Welcome any comments and suggestions. Here the QR code for our project URL. Thanks again. That's all.